Hi guys, this is Commodore Sam coming to you again. Today I've got the third part of our series on Drive Speed Challenge. And what I've got for you today is the RAM link. Now, we discussed the RAM link in the very first video. We touched on it at the very end, where we were basically comparing the speed of several different types of drives, as we went through and looked at all of the different Jiffy DOS drives that we had. In all of those cases, Jiffy DOS was being provided by the RAM link. And so uh, there's more to the RAM link than just providing Jiffy DOS or providing a parallel port to a CMD HD, or there's also internal RAM, which we tested at the end. Now, in addition to I say internal, actually, what we tested in part one was not the internal RAM of the RAM link. It was technically the speed of the cartridge that was the REU that was plugged into the RAM link, because the RAM link was using its memory. So a RAM link, uh, basically, when you plug in a REU or a RAM expansion into it, it partitions it off as part of its drive structure, and gives you access to it as a RAM drive. Something that doesn't happen normally when you take that RAM expansion and plug it directly into a Commodore 64. So with that, we're going to dive into the different ways that you can use a RAM link. And basically, there's really three different ways or types of RAM really that you can use with a RAM link. The RAM link has a RAM card internal to it that plugs into an internal port. And that RAM currently has 16 megabytes, and that's the limit, 16 megabytes. In that in those are in the form of SIMs sitting on that RAM card in the RAM link. In addition to that, you can plug in either Commodore or other branded. This happens to be a clone of a Commodore REU, using the REC chip, that the same chip that comes out of a Commodore 1764 or 1750. And so this is a clone, and it's actually has 1 megabyte of RAM in it. Okay, so RAM card, 16 megabytes internal, external REU with 1 megabyte, and then also you can have GeoRAM, or in this case, a knockoff or a reproduction called NeoRam. Yeah, it's got some improvements. Both of these clones have some improvements over the original. But and so we're going to look at it. But this NeoRAM is 2 megabytes. So keeping score, 16 megabytes in the internal RAM card, 1 megabyte on the REU that I have here. You can get those bigger, and 2 megabytes on the NeoRAM, which is the GeoRAM reproduction. Okay, so with that, that's what we're going to have today, and I'm going to reposition the camera and bring you in a little closer, and we'll get to looking at these drive speeds. Okay, guys. So I'm sitting here again. We're on the RAM link. We're on the 1750 REU, and have that plugged in. And so I just wanted to show you. I listed the partitions out here, and you can see that I've got a RAM link 1 and a RAM link 2, both native. Now that 0 up there is a system partition, and we don't access that. We're only going to access this native partition. And just to keep the everything fair, I'm gonna actually unplug it do three different tests with three and with not without the other one being plugged in. You can disable and switch partitions and do a lot of things. You can do it absolutely different, but I want to keep it simple, stupid, and use the KISS principle here and make sure there is no incompatibilities or anything else going on. That it's just 100% pure. So let's get right into testing. And we're going to start the same test that we did in part one, so you can remember what the speed was with that, right? So I've got my program over on drive 11, and that we've been using for our benchmarking. And so, again, if you hadn't seen my other benchmarking episodes, go look at part one and part two. But part one actually had this test in it. And so I'm going to, if you remember, we can only test drives 8 through 11. So I'm going to hit the swap 8 button here on the RAM link. And so now the RAM link is sitting in at drive 8. And we're in the first partition, which means we are actually on the 1750 RU clone. So I'm going to hit F3 to do our save. And you'll remember that we got this 87x score, so 87 times faster than a 1541 stock, and you can note the 32,111 bytes per second, pretty fast. All right, and so now I'm going to do the F5 to do the load, and it does it in 1 decisecond. Now that is 1,124 times. And so basically, if you look at the bytes here, bytes per second, the file size that we're transferring is actually only 44,956 bytes, big, and it accomplishes it in 1 second. And so that's the way we get our score. Now, I don't believe this is as accurate as I would prefer, but I don't have a choice. The maker of this program is not currently modifying it at all, so I can't make a bigger file to transfer for these bigger ones. Remember, it has to stay small enough that it can actually be tested on a smaller drive. It would be nice to have a second feature where we could do a bigger file to get a better score, possibly more accurate score. Can't prove that it's inaccurate, but it's taking 1 decisecond to transfer this file, which gives us that 1124. So this is the exact numbers that we got in part one when we did the test comparing the other drives to this. So with that being said, now what I'm going to do is I'm going to turn off the 64, and I'm going to unplug the power out of my RAMLink, because you're not supposed to change the um, cartridges with you're not supposed to change the cartridges with power connected. So I took that out, and I'm plugging the power back up. I like to always just give it a second just for it to stabilize and everything. And then we'll turn it back on. Now, when you'll always note that when with RAMLink, when you turn your machine on, it's injecting I'll call it injecting. It's injecting the Jiffy DOS into the system, so it takes a second for it to come up. But just to test that working, I'm just going to go to 16, hit F1, and so you can see that I've got the full 16 megabytes worth in blocks there, the full 16 megabytes worth of data on that drive. So again, same thing we did before. I'm going to go over here to 11, run the program. And I know I could have moved things around, done a little bit different, but anyway, uh, just trying to stay with the same process. So I'm gonna hit the swap 8 button on the RAM link again, and then I'm gonna hit the F3. And you'll notice something interesting here. Only 51 times. Okay. 18,732. I'm going to hit F5 and it's 125 times. That's a way less. It's one tenth of the speed that we were at with this. This plugged into the RAMLink is almost 10 times faster uh, than the internal RAM cards. So just make that in a note. Now, it makes it interesting. Why is that? We'll talk about theories here in a little bit, but why is that? So we've seen what our score there is: 51 and 125 for the save and the load. Just going directly to the RAM link all by itself, getting to the RAM card that's internal, that's 16 megabytes. Now that's the nice part about this is it is a full 16 megabytes inside here. Might be a little bit slower, but it's a whole lot bigger, right? As opposed to the 1 megabyte that this is. But what about our 2 megabyte? What about our two megabyte NeoRam? So same thing. I'm going to turn this off. I'm going to unplug the power out of my RAM link, and I'm going to put this NeoRam back here in the back here, and then I'm going to plug in the power to the RAM link, and so I'll give it the second that I normally give it, and then turn it on, and we're going to give it just a second here. Like same thing before. If I go to, I'm going to do what I did before, just so you can see what it looks like there. Hit F1. Notice that I don't have as many blocks. That's because that's 2 megabytes worth of blocks on that partition one. If I went to partition two, um, and hit F1, I'll see my remaining. So this number here is the 16 megabytes minus the 2 megabytes up here, because I can only have a total of 16. So I got these two partitions, right? Okay, so with that being said, I'm going to go back. I'm going to change my partition back to 1 because we want to test partition 1. We want to test the NeoRam, and because we've already tested this RAM here, right? All right, so I changed the partition on this back to 1, and I'm going to go and run my uh, program off of 11, and I'm going to put this. I'm going to hit the swap button again on the RAM link and hit F3, and you'll find something interesting here. All right, so this is 18x for this, um, and if I hit F5, 125. Interesting, right? Okay, watch this though. Seems to be inconsistent sometimes. What I have noticed is on this Neo RAM, the first time I access it, it's a lot slower than the second time I access it. I don't experience that on this, but I do on the NeoRam, and I can't explain that. Um, but what you will notice is this 51 and this 125. Guess what that is? That's the same exact speed as we were getting off of the RAM card. So apparently, the NeoRam and the RAM card are very similar in their ability. So what makes those different? And so that's my question, right? And again, I am guessing here. I'm no electronic engineer, but um, the internal card here has no REC chip. It doesn't have that square chip, and in the 1700s it was actually a dip chip, but a longer, skinnier chip. But in the 1764 and the 1750, And in the clones, in this particular clone at least, it uses the square chip, the same as the 1764 and the 1750. I have to believe, since there's no square chip in these two, that CMD is somehow recognizing this CMD, uh, chip, and actually using it for the load to speed it up, because it's 10 times faster. This is 10 times faster than the internal. It's 10 times faster than the NeoRam. Uh, so with this plugged in, I get a significantly faster speed. Now, I wish I had an original 1750 to try. I actually sold the last one I had, and because I had this, and I didn't feel like I needed the bigger, bulkier Commodore one. So I can't really test it today. It would be interesting if somebody else wanted to test it using this program, and leave a comment about that. That would be interesting to see. But y'all try out, if you have a RAM link, try out these various RAM tests, and see what you think. See if you're getting the same results. Now, if you know anything about RAM links, sometimes that testing can be quite difficult, or you don't want to do it, right? Because you may have something on the RAM drive, and if it loses power, it loses the information that it has on the RAM drive. And to plug in a new cartridge into the RAM port, CMD tells you in the manual that you need to disconnect the power to the device to be able to plug in a different RAM expansion. So it is a kind of a big deal to have to do that. That to me is probably the only flaw of the RAM link, if it has one, because it's super sweet in every other way. It's super sweet when in accessing a CMD HD drive super fast. It's super cool that it injects the Jiffy DOS into your computer, where you don't have to change chips out inside the computer. It's super cool that it allows the expansions, and it can do all the speed and everything. But only problem is you got to keep power to it for the memory to stay intact. As soon as so it is completely erased when you take the power away from it, which means you can't easily swap out in this back RAM port. Now, the RAM link does have this front port here, and this is just a pass-through port. It's just passing directly into the 64. All it requires is for you to have the computer off, because it's not really being looked at by the RAM link itself. So the fact that the RAM link has power doesn't prevent you from putting something into the front slot, just the computer. In fact, normally in the way I have my RAM link normally configured, is I usually have my Vision Basic cartridge in the front slot there. I'll usually have them both full. Occasionally I will take this out, and I'll use my Wi-Fi cartridge in there, if I want to get on a bulletin board or something. But I leave this REU in the back slot all the time, uh, for obvious reasons. Anyway, well, that's all I've got for y'all today, and I appreciate you tuning in. I will show you, just like I have done before, the results that I got off of this. I'll move the camera around and zoom in here. Um, and so you will see, the you can see there that the RAM card 16 megabyte was 15x for the save, 125 for the load. With the Neo RAM, it was exactly the same. But with the 1750 clone, that's when we achieved the really fast speeds, especially on the load. But it was pretty significant on the save as well. Anyway, that brings us to a close. And guys, I really appreciate it. I hope you watched the other videos. I still have some more to do. Hopefully some, even some more surprising finds. I was surprised by a lot of these numbers. And that's what a benchmark will do for you. It will erase, the some of the ambiguity out of uh how we think about these drives. So see you next time. Thank you.